board. The floor is yours.
Okay, thanks, Marcelo. I wanted to joke with Marcelo that it's dangerous to say that a donor can only speak for 5 minutes, but in truth, I will be really quick because there are many more interesting people to hear from today. Just to give a perspective on why IKEA Foundation was one of many donors that came together on this pledge, why it was appealing for us. I'll give you 3 things that I'd love to just mention really quickly. First, it is a far-reaching topic. It's agricultural waste, it's landfills, it's gas, and all of the kind of emissions. And that means that we can do much more than we wanted to. Second, the effects of it can be seen immediately, as I think you'll hear from some of the scientists today as well. But thirdly, and this is a really unfortunate admission to make, and it goes very much personally to why I as a donor wanted to be a part of this, when the Paris Agreement was signed in 2015, we promised collectively by 2020 that we will have peaked emissions. And the fact that we have put so many tools into place to do that and have failed to cut carbon means that a fast-acting super pollutant that lives for a shorter period of time in the atmosphere but heats 80 times the degree of carbon was tremendously appealing to help us get back on track. So those were some of the motivations behind getting involved in this. The second is the appreciation that I think we and other donors have for how policy and science can be linked very productively. Science, as many have said, is not partisan. It is not political. It is just factual. And donors can often be accused sometimes of funding things that are normative, the world we want to see. But this tells it as it is. And when science can provide the evidence to policymakers who are desperately in need of gaining traction with issues and agendas they're trying to move forward, it is a marriage made in heaven, because they can also get some immediate impact and reward for the things that they have bravely pushed on. And I think that really merits quite a lot. I think what we're going to hear about a lot today with landfills is also exciting, because even though much is known so far about what satellites can tell us and what field visits can tell us, we still are at the very beginning of how to manage the food waste problem in particular, and how to turn it from something that we identify as a problem into a livelihood-generating opportunity, whether it is through reusing organic waste differently, reducing the amount that we produce to begin with, or many, many other things. And I think this is where donors get excited, because of the potential for innovation, the potential for recreation, and changing the lives and livelihoods of people in the surrounding communities that are heavily affected by this. We were talking earlier just about mayors and what they see in their own community as a potential. So with that, let me leave it here, under 3 minutes in fact. So Marcelo, I did you okay? And we'll get this back on track, and I really look forward, as long as I can stay, for a few moments longer, to the other panelists. Thank you.
Thank you, Liz. It's great. And yes, we've been able to mobilize around $60 million this year on methane mitigation globally, where we hope to have many announcements at COP. I'm not going to undermine any of them at this point, but we'll start off with this great panel. I'll just introduce the panelists. We have Ilse Aben. She's senior scientist and co-principal investigator of TRPOMI at the Dutch space agency ESRON. Is that correct, or did I butcher it? Okay, there you go. We have Maximiliano Proaño. He is the Vice Minister of Environment for Chile, who comes with a methane reduction plan for this COP. We also have Tim Searchinger, who is a senior research scholar at Princeton School of Policy and International Affairs, and a very great collaborator on agricultural methane. And we also have Stéphane Germain, CEO of GHTSAT. Also online, we're going to have a presentation by Riley Duran, who is the CEO of Carbon Mapper, who will also speak. But we're going to start off with Ilse. She's going to provide us some really exciting data that we're actually launching today. So here's the floor is yours.
Can I move the presentation forward? Okay, so great. So it's great to be here and getting this opportunity to... Oh, but it's going to be a lot. Okay, well... Okay. So using satellites to support governments and companies to reduce methane emission. I have to say a few words about a TRPOMI instrument, which is a satellite instrument that is initiated in the Netherlands and that is realized together with ESA. It's launched 5 years ago, and it's part of the EU Copernicus program. the unique thing that is relevant here with respect to methane is that TRPOMI achieves daily global coverage. We see the entire Earth atmosphere in one day with individual observations looking at an area of only 5.5 by 7 kilometers. And that makes it ideally suited to detect and locate globally these so-called methane emitters. Localized, very localized, huge sources of methane. Please, next one. And this is showing you an example. This is a single overpass of TRPOMI over the northeastern part of Australia. Looking at Queensland when we get it back. This is coal mine country. And what I hope we'll get back now is you'll see 3 plumes of methane. And these are 3 clusters. But it's gone, right? Is this better? I don't think
there we go.
This is not better. All right. So we have 3 plumes of methane that you see, and it turns out that these are clusters of coal mines spitting out methane. The most northern one is actually a single coal mine. It's so isolated, we know it's just one coal mine. Turns out to be a surface coal mine. That's very special, but the point is that it's responsible for only 1% of the coal production, while the emissions that TRPOMI measures are equal to 24% of what Australia is reporting for all its coal mines. So this is a typical super emitter. Next one, please. Now, what we now get with TRPOMI for the first time is a global view on super emitters of methane. And this is a map that we get when we look at the data from 21. Super emitters across. And although I just put that an example in Australia where we know one of those signals comes from an individual mine, in most cases with TRPOMI, looking at an area of 5.5 by 7 kilometers, we can't really tell what the actual source is. There's just too many different possibilities. So what we've been doing is we've been teaming up, please, next. Yeah, with GGSat. And, well, Stefan is here on the panel, so you'll hear from him. That's a private company from Canada that has designed these dedicated methane satellite instruments that measure methane at 25-meter resolution, so at facility scale level. But they can only look at an area of 10 by 15 kilometers for each observation. So they need to target and need to know where to look. And we've been collaborating now for about 3 years now, very successfully, because TRPOMI can actually pinpoint where to look. And so this combination is really great, and I'll show you a few examples of that. Nowadays, there's also people have used land imagers, like Landsat, Sentinel-2, Prisma, that basically are designed to characterize the Earth's surface at high resolution. Under favorable conditions, they can also see methane super emitters, particularly, for example, big leaks with oil and gas infrastructure over desert areas. So I'll start with an example of that in Central Asia. This is showing you the west coast of Turkmenistan. One back, please. A couple of hotspots that we see with TRPOMI, these red dots means enhanced methane. And what we did here with University of Valencia, they zoomed in with a few of those land imagers, Prisma, Landsat, Sentinel-2, yes. And they actually found that under these 6 hotspots of TRPOMI are 29 sources. They detected 29 sources. You see 2 of them here, 2 of the plumes. And if you look on the right-hand side for the most eastern plume, you can actually see that it's coming from an open pit flare. And we found that out of the 29 sources that we detected this way, 24 are not burning flares. So gas is just being emitted, and then it's mostly methane. So that's really low-hanging fruit if you want to do something about methane emissions. Okay, but then if we turn to landfills, the story starts to become a little bit more complicated. And then these land imagers cannot detect methane emissions. It's just too complicated. So here we see an example which we did with GGSat. We show on the left-hand side an image of TRPOMI with enhanced methane over Buenos Aires. We provide that location to our colleagues at GGSat, and then they zoomed in and they see what you see on the right-hand side. These are huge emissions coming from a landfill in the city center of Buenos Aires. And you can even see it's coming from the active part of the landfill, which is the most western one, so where the garbage is still being dumped, which makes sense. If you look very carefully, you even see a bit of dark purple, which is lower methane emissions coming from the closed part of the landfill. Yes. We've done this tip and cue with Tropomi and GGSat for urban areas at a few locations now. We published this recently in a scientific paper looking at Lahore, Delhi and Mumbai, and we also see emissions from landfills. Now, Bram Maasakkers, who is the first author on this paper, estimated also the emissions using Tropomi for the whole city and compared them with what is emitted by the landfills. And with Buenos Aires, you see, for example, that the landfill is responsible for 50% of the total methane emissions of the city. Now, we also see these emissions in Europe. Here is close to Madrid. We have two images of Tropomi. You see a clear plume. We provide the location. Zooming in with GGSat, they found emissions at two different landfills. Yes, please. Next one. Now, so what I'm very happy to be able to announce here that we have started now an initiative building on what we've published in this scientific paper on these 4 landfills, but now expanding this globally. So we want to study emissions from landfills globally, and together with the Global Methane Hub, ESRON and GGSat, we started this new project to characterize and study, monitor landfills globally, also working together with NGOs and local partners to work on mitigation, because in the end, we need to reduce our emissions. And the map you see below shows you, firstly, Tropomi urban hotspots. So in orange, you see hotspots of emission of methane across the globe. There are some 40 of them. And they were used to do target observations with GGSat, and in a large part they saw a lot of emission from landfills in these locations. And in addition, GGSat also targeted other landfills, and these are all the black dots that you see. So this map contains about 150 points, locations where we see methane emissions from landfills, basically. And this is what we want to do. Next one. We want to study these landfills, and this is just showing you what we will do in the coming months. The first phase of the project, this is looking at Casablanca. This is a Tropomi image, and if you zoom in with GGSat, next slide please, you actually see the landfill emissions coming from a landfill. Next one. And another one in Istanbul. Next one, and when you zoom in, you really see it's coming from a landfill. So, basically, my advice is we have no time to waste, and this is, I hope we can help solve, or at least start solving part of the problem here.
Thank you so much, Ilse. So very exciting, because initially, for example, Carbon Mapper had been working with this in Los Angeles. And they were able to highlight those leaks and intervene those landfills and actually document 90% reduction of emissions. And for the mayor or for the environmental enforcer, that means less complaints because of bad odors. So we're going to have a mission this summer in Chile, Ecuador, and possibly Argentina to track some of these landfills directly and then follow up with satellite information. So we're going to, as I'm extending here because we're having a presentation being set up. We're going to watch a presentation from Carbon Mapper. This is Riley Duran. He is the CEO of Carbon Mapper, and he has been also working with ESRON, GHGSat, the whole community that has been working on methane observations for many years. And they also are going to be working on landfills in a grant with Grantham Foundation that's going to be supplied details very soon. So, okay, so we'll just skip that part, and we'll see if we can play it at the end. Okay. So, of course, this is the resilience of professors and donors. So I'm going to start with some questions to Maximiliano Proaño. He is Vice Minister of the Environment. What value do you see in having emissions data from landfills, and what benefits do you see outside the climate agenda?
Thank you, Marcelo. First of all, I would like to thank you for the invitation to participate in this event organized by IPCC, the WMO, and Mary Foundation, together with Global Methane Hub, and congratulate them for their tireless compromise to support those working on methane mitigation efforts. Chile has been developing a work agenda that seeks to reduce the impact associated with the final disposal of organic waste in landfills or dams, promoting the reduction of the generation of this type of waste, its differentiated management and valorization through technologies such as composting or biodigestion, and the capture of methane gas in landfills. Thanks to the cooperation agreement between Chile and Canada, the organic recycling program was launched, which supported for 4 years the implementation of projects related to gas capture at final disposal sites or the separate treatment of organic matter through composting or anaerobic digestion. There are 22 ongoing projects supported technically and financially, with which it is expected to reduce 9.5 million tons of CO2 by 2040. With the support of Reciclo Orgánicos, in 2021, the National Organic Waste Strategy was published with the goal of moving for 1% to 66% valorization of organic waste generated at the municipal level by 2040. This year we are working on an organic waste bill which proposed to introduce adjustments to our regulation regarding waste management that considered the establishment of obligations for separation at source and to offer alternatives for the differentiated management of organic waste. 2, the modernization of the financing system for household solid waste management services. And 3, improving governance and waste management planning instruments. Chile is working on strengthening its NDC, increasing ambition in all its components, as well as paying special attention to transparency, clarity and monitoring of the target sets. We also seek to increase ambition by strengthening commitments to reduce methane emissions, ending with the growing trend of methane emissions. This is what we have achieved this year. We expect that in the NDC update in 2025, we will present more actions. Finally, we are at a critical juncture in the climate crisis. Countries must commit the increasing ambition in order to meet the Paris Agreement targets. Climate change is not a problem of the future, it is an issue that must concern us and occupy us today. Access to satellite information that makes methane emissions visible and quantifiable will allow us to strengthen the development and implementation of policies that focus on emissions from the decomposition of organic waste, as well as others that focus on methane emissions for other sources. Thanks.
That's great. Thank you so much, Vice Minister. We're very happy to have supported the development of the organic waste law, of course, the methane mitigation target, and we hope to continue to use this information that we get to provide tangible benefits for people, to see the reductions of emissions now. Not a promise, but something you could take right away and see right away. So we'll have the presentation now from Carbon Mapper, and then we'll get back into the rest of the panel.
Hello and good afternoon. My name is Riley Durham. I'm Chief Executive Officer for the NGO Carbon Mapper, as well as a research scientist at the University of Arizona. I apologize for not being in person today, but I know you're going to get me into my colleagues on that. I'd like to offer a few today on the outlook for methane decisions for space based on our research in this area in the last decade. The carbon effort is built in a nonprofit organization with public mission to make actionable localized methane decisions data available. It's also the name of a satellite program that we're implementing through public-private partnership between California Research. We're on track to launch this expanded constellation will provide daily monitoring of our hydrogen resources. And we will make all of our methane decisions. Next slide. So this is our contribution to emerging global systems methane monitoring. This artist concept on the right illustrates the use of multiple satellite observations, aircraft, and service measurements to apply what we refer to as a tiered observing system strategy. Our experience in working on this over many years under NASA-funded research programs is there are two primary types of monitoring. What we call type 1 is support for aggregate scale accounting, for example, inputs to national scale testing. Type 2 monitoring refers to direct mitigation efforts. This tends to be more focused on very focused facilities operation. The big takeaway I have from these efforts is that no single system is designed to address all methane use cases on really portfolio of methods. And that was part of what we had in mind. This slide shows a number of use cases for methane mitigation efforts. It ranges from leak detection and repair for less operations to more quantitative estimates of methane intensity across supply chains, efforts to reduce legal and illicit leaking, and importantly, non-fossil fuel sectors. So remember, 2/3 of methane from anthropogenic activity comes from the waste sector and agriculture. And so it's important to help inform best practices and investment priorities in those areas where possible by alternative causes for operations. Also important to understand there are two general categories of methane emissions that can inform monitoring mitigation strategies. One category is point sources, and the other one is area sources of variation. The carbon map we have chosen to focus on high-emission point sources because our airborne studies show over multiple regions that in many cases up to 20 to 60% of regional emissions can come from a small fraction of infrastructure. This is so-called super. It doesn't occur in every sector, but it is pretty widespread, and I've listed some of them here. And the strategy innovation here is that if you can locate and fix outliers, you can make a big dent in methane emissions. At least that's the idea. Area emissions are equally important to address, but it often involves monitoring of large populations, smaller emission sources, or storage sources. And again, the point here is it's important to understand which problems are tackling and how to take the storage system issues. Regarding the methane super-emitter topic, we see this activity in most sectors and regions. We see it in the energy sector, oil and gas, coal. We see it in waste management as well as agriculture. We also find that many of these emissions are intermittent and episodic. About half of the ones that we see are not persistent. That is, they vary on time scales of weeks, months, hours. And so this animation on the lower right illustrates this permanent gas reduction where the size of the circles indicates the location of emissions. This means that monitoring systems need to account for variability and intermittency. And this is why we need to rely on just assessment. We also learned in our pilot program to aircraft in multiple U.S. states that in many cases, facility operators, when armed with actionable methane data, will take action to mitigate emissions. And these are some examples of California shown before and after images of methane sources at landfills, at gas production sites, gas pipelines in urban areas where the emissions were found, notified to the operator, and we verified all observations that the emissions are gone. So this is I think, a good existence proof of how we can scale this out. Now, colleague, Professor Robbins, who talked about emissions from landfills to the waste sector, I wanted to share that this is both a challenge and an opportunity for all global methane parties, because waste sector methane is perhaps the most ubiquitous phenomenon across all regions. And so our experience in flying our aircraft over 17 U.S. states, we had nearly 240 landfills that report their emissions to the Environmental Protection Agency. In about half of those cases, we see evidence of super emitter activity, including cases of both under and underreporting of greenhouse gas reporting programs. And this just shows that there's much to be learned about emissions from even managed systems, as well as prioritizing efforts to number unmanaged landfill sites. And with that in mind, I want to point out that we do have a big announcement coming out on November 17th with our partners, methane hub, RMI, and others about your program to scale up this. So I'll wrap up now with a few thoughts about what we're planning to do with the carbon microsatellite program. When we launch the first 2 satellites next fall, we initially plan to do an annual global survey that's looking at the whole area of this map, where we don't necessarily know in advance where the high emission sources are, but we're going to go with the system. It's completely first, if you will, super emitter map in the first year. Additionally, the purple areas where we plan to sustain monitoring at higher frequency, at higher areas. Initially, that will be weeks and months for revisit. Ultimately, we can hope to reduce that to a few days as we increase the size of the constellation. Additionally, this observing system is designed to look at emissions from oil and gas platforms and medium ships using blend mode tracking sunlight on the oceans is something we've been testing over the last several years, including a movie published about emissions in Gulf of Mexico back in summer. We also plan to take advantage of observations from our colleagues at Vinculación and India's methane sector. They detect island regions or hotspots at the southern Imperial region. We will have the ability to work with our partner China to task the satellites to rapidly follow up on those high emission events. This is called something new. I expect Professor Robbins also talked about this, and we are contributing to it as well. Last but not least, timely data availability and transparency really are key to uptake and adoption and use of scale for action. Our website, our data portal here, it shows that almost 8,000 methane emissions detected daily for several years are airborne observations of the U.S. And we're set to expand this over the next several months outside the U.S. to go with aircraft observations and, of course, satellite observations and online starting next year. So with that, I'll wrap up. I'll thank you all for your attention. I wish you the best of luck with COP27. This is an incredible meeting, as you all know, and I wish you safe travels. Thank you.
Thanks for Riley for his great presentation, and we'll continue with Stefan. Of course, it was a great surprise to see the major super emitters were actually landfills in many ways, maybe even bigger than oil and gas operations, which we expected somewhat. What was the main surprise you saw in your initial work in landfills, and what next steps do you see in turning that data into action?
Thanks, Marcelo. So let me just introduce the audience first to what we do. And in fact, we do a lot of what you just heard. So GHGSat is a company that today operates 6 satellites. They're in orbit today. And we monitor facility level emissions of methane everywhere in the world. We've been doing that since 2016. We launched our first satellite in 2016. As I said, we have 6 satellites in orbit now. We're launching 6 more next year in 2023. And our mission is to work with all stakeholders, operators, governments, and third parties that are interested, financial services sector, NGOs, that are interested in better understanding emissions from individual facilities so they can eventually control them and reduce those emissions. So that's what we do. And so I certainly want to acknowledge the work that we've done with ILSA and ESRON in the last few years, because that was really the start of looking at landfills for us. We discovered, I think, that we could actually be very complementary in how we work together, because as ILSA pointed out, Jacomi can see the whole world every day and see hotspots, but can't necessarily pick out exactly what's going on within a hotspot. what we can do is we can zoom in. Jacoby's kind of the wide-angle lens on the camera. We are the telephoto lens. We can zoom in and really see what's going on. And so when Jacoby would find hotspots to look at, we go look. And at first it took some back and forth and took some learning about how to work those tipping and queuing events together. But over time now, we've now identified and verified hundreds of sites all around the world of all kinds. So it's not just landfills, but it's also oil and gas, coal mining, and even natural sources. So to get to answer your question, I guess what surprised me most is just how much we saw. Initially, frankly, I wasn't expecting that we'd see that many landfills as super emitters everywhere in the world. But we truly see them everywhere. So where I'm from in Canada, we've seen dozens of landfills across the country that are managed landfills with active gas recovery systems, and yet we still see them. In the United States, all over the United States, we see landfills. Same idea. Many of them are managed landfills with gas recovery systems in place. And actually, we even had examples where we've seen no emissions at a site, and then there's been a power failure because a hurricane came through. And after the power failure, we saw enormous emissions. So you can see the immediate benefit of having a gas recovery system in place at one of these landfills. And then we go more broadly afield and start looking at Latin America, Europe, Asia, and India in particular. We saw very large emissions. The largest emissions we see in the world from a landfill are in Buenos Aires, and we actually had that example in the slides that Ilse showed. But if you look at a single country, the largest emissions we see anywhere, combined emissions from landfills, are from India. And that's probably a combination of factors, probably the weather, the mix of waste, waste management practices, whatever the underlying causes may be. In India, by far and away, as a country, is the largest source of landfill emissions we see in the world today. So I guess I'm surprised by the magnitude of it. I applaud the efforts of the Global Methane Hub and responsible organizations to tackle landfill emissions. This is a problem with a known solution. I think the challenge is primarily in the implementation, in the local politics, and the funding of the efforts to mitigate these sources. But we will be there. We are there now, and we will continue to be there in working with the Global Methane Hub, with our partners, to find these and mitigate these emissions, because they are, in our view, a quick win for all of us. So thanks for the opportunity.
And we got some interference there. Somebody doesn't want landfills to be reduced. So and following up on what you're saying, we were in C40 2 weeks ago, 3 weeks ago, and we met with multiple mayors from Mumbai, from Delhi, from Bangalore, from Agra, Dhaka, and we got so excited they could actually solve this. They could actually go back to the constituency and say, we're emitting less. And so the solution is very well aligned. It's something that has a global benefit. It's not only about global emission reductions. So I'll pass it over to something a little bit more complicated, because obviously we have a long way to go with methane observations in the agriculture sector, in which Professor Surjinger works. They can only tell so much. And a lot of emissions have been shifting. And we're supporting many countries reducing emissions, and we can see that Europe and US emissions on methane might be reducing, but there's going to be a rise in developing countries as production patterns are outsourced. So I just wondered, if you could tell us a little bit about the work that you've been doing and why better emissions accounting is going to be crucial to see whether we're actually reducing emissions or we're actually just shifting them somewhere else.
Thanks. Yeah, and I don't know how to do any of the incredible stuff that other people are going to do. I'm a consumer of this information rather than a producer of this information. And so let me I work on agricultural emissions, and agriculture is somewhere around 45% of methane emissions. Obviously, the land use change is about a quarter, and nitrous oxide about a quarter of all human emissions. So, unfortunately, of course, this incredible information is harder to use for agriculture. I've been wondering, listening to these presentations, I think the best opportunity to use satellites might be at least to get some area source information on concentrated rice production areas. It can give us an idea of how many emissions we really have from rice. Of all the things you do, I think that may be the most directly applicable. Rice emissions are somewhere between 7 and 20% of agricultural emissions. The estimates vary enormously, and the reason they vary enormously is not only, obviously, are we using emission factors that are uncertain, but the water management regime is really unknown. And the basic rules are the longer things, consistently things are flooded, the more methane we have, and we don't really know how most rice fields are flooded. So actually one use of satellite imagery can be to help us better understand how frequently these areas are flooded. But then if we can then tie that in, even in some places, actual methane measurements in that area, it might help us to nail down the rice emission issue. And the nice thing about rice is we think we know how to control rice emissions. So if we can actually better calculate what they are, we can actually do something about that. Of course, 2/3 of agricultural emissions are from enteric digestion. I don't think, unfortunately, we're going to capture those. Yeah, well, I'd like to hear about that. I mean, help us to kind of nail down those emissions. That's a question I would then have for you. And then the rest are from manure management facilities. And again, probably the best job there is more ground-based observations. But I think there would be an interesting question once we have better ground-based observations and can, in areas, back calculate through this combination how much is coming from these agricultural sources, whether we'll be able to use satellites then to verify the changes. In other words, if we know the other sources better, maybe we'll be able to then find differences, the agricultural sources. So those are some thoughts I have on hopefully trying to use some of the agricultural information. Regarding just this brief comment about outsourcing, agricultural production is going to grow about 50%. And the growth is in developing countries. And policies in developed countries are kind of shifting toward developing countries. Europe's climate plan actually involves taking about 20% of its crop land out of food production, which basically is going to force more food production elsewhere. So I do think that this ability to be able to track, and particularly livestock production is growing. Dairy is growing at a rate of about 70% between 2010 and 2050, and beef production will grow probably about 40 to 50%. And again, most of that is in developing countries. So I think that somehow, I'd be curious to hear what you think about our ability to track some of this territory.
I'll respond to that, or we can also open up for the floor, if anybody. Okay, so Daniel, you want to ask a question?
Thank you, Daniel Tylan from the Commission for Environmental Cooperation. So I have a question for you, Stefan, and I don't know if Riley's listening, but this is our source of information these days. Can you put, like we see storms, can you put methane plumes on a cell phone? And the second part of the question is, if not, is there a better way to get plume information to common citizens?
Wow, that's a great softball for me. Thank you. The answer is yes. In fact, yesterday we just announced a platform where we're providing a free view of the world of methane, and we've already had hundreds of subscriptions since then to the service. It's available on the website, which you could get on your phone, and we also are on a platform that can be adapted to mobile. So the answer is yes, it's available now. And if you're curious, it's called spectra-basic@ghgsat.com.
So it's fun because you can look at your neighborhood and see where the biggest methane leak is. Here's the nearest landfill. Any other questions from the public?
I think it's on, yes. So the putative goal of the ability to measure these point sources is ultimately to reduce the growth rate of methane globally. And yet, in many cases, we still don't understand why the methane growth rate is what it is. So, what do we see based upon the new constellation of instruments that we bring to the table? What do we think would be the timescales for which we can observe at the global scale the mitigation actions that we are seeing that can be observed from these individual satellites? So how would we tell that those mitigations are actually changing the planetary gradient of balance based upon the measurements we're now bringing to the table?
Give that one to us.
Okay, great, Kevin. Yeah, you're putting everything on the table now. So obviously, I had another presentation today, and I said, we're just starting. This is a new era of satellite observations, and how we're going to use that to try to, first of all, mitigate, so reduce methane emissions. And I could add to that, to get a better picture of what is happening with methane at a more larger scale. Because obviously, it's ridiculous, we don't understand it yet. It's been increasing by, we can only guess, speculations. Each time in scientific journals, we get different theories about what it is. And so, what you're putting is a very complicated question. But I think we need to not be afraid that we don't know yet the exact route how to get there. We need to take advantage of what is being developed, and I have faith that we're going to move forward on both areas. I think we need these super emitters are really low-hanging fruit. We should not ignore it just because it's not going to answer your question, because it's going to be helpful for a lot of societies, etc. At the same time, and Riley had it in his presentation, it was really good to see that he said we have the point sources, the area sources, livestock is important, so instruments like tropomi, but certainly not tropomi alone. Future instruments will help address the more, let's say, bigger picture questions that you're putting on the table now. And but I think we should use what we've got and not forget about the bigger picture, not forget about the bigger questions. What are wetlands going to do in a changing atmosphere? I mean, we need to address these as well. And some studies are already done using tropomi, because it's not only looking at super emitters, but it sees the bigger picture. But yeah, we need to put in more effort. We need to increase the effort on all fronts, and then hopefully one day we will meet each other. We'll have some answers to that question.
At least my experience is, and carbon mapper also showed, you could actually reduce those emissions. You could go back after, see if the reductions exist. Then you can go back again and see it actually rose because you went back into your old ways. And I think it's really important that, for example, at a city scale, it could be something we could actually really take hold and improve operations. But I'm really good, wondering, for example, I used to be in Maximiliano's seat. I used to be vice president for Chile. And I would have loved a tool like the one that we have available. How do you see, for example, the future of enforcement? Vinculación, looking at this with these tools.
Yeah, to be honest, probably in Chile we have moving fast. We are moving fast because we are in a quite critical situation about waste management, our waste management system. The main reasons of that are the imminent end of the useful life of the existing final disposal infrastructure. The difficulties and deadlines associated with the location, obtaining of authorizations, construction and operation of new facilities. Not in my backyard operates also, so the social conflict that projects can bring with them, the structural underfunding of the municipalities in terms of waste collection, transportation and disposal. So yeah, the disposal infrastructure is in a worrisome situation of the 115 active sites. 75 are the useful life expired with by 2022, and 14 more we have their useful life expired in less than 10 years. So yeah, and normally it takes around 10 years from a project is planned to is built to the total building of this landfill. So in this context, the proper public policies, planning, and accuracy data for this the content of this activity is very important for us, and also financing of course is very important. We created, our government created a multi-sectoral coordination between health, regional development and environmental ministries, because the coordination of also of the public policies and initiatives were very bad in the past, and now we are assumed to that we need to hurry up, so it's necessary going faster. So yeah, progress has been made in improving the standards of final disposal, but much remains to be done. There are, as I said before, 116 active disposal sites in the country, which only 42 sites comply with the regulations. Fortunately, most of the waste arrives of these 42 sites, but there are a lot of to do still.
Great, but and I see many mayors, as you were saying, the life operations is ending, and some landfilling is occurring 700 kilometers away from the site. So competing with composting is much easier. And then with the new tax and trade scheme with emission compensation, there will be an incentive to actually compost instead of landfill, or cap that leak instead of letting it just leak. So I think there's many objectives that are aligned. That's why I'm excited about this work, because it's not just a global mandate of reducing emissions. It's a mayor that will extend the lifetime of a landfill twice as long if they're able to divert organic waste. And this problem that he just described is a global problem. There's not a place in the world where it's easy to get a new landfill. There's not a place in the world where the time is not running out. And this is a ticking time bomb that we're going to be addressing together at the Methane Hub. So I wanted to thank you all for this. We're going to get the panels back on track. And so I'd like to offer a warm applause for the panelists. And so we'll see you with the other methane actions this week. Thanks so much. And